Okay, we're gonna start with some basic equation. This one's pretty basic. I think I mentioned this before, but I really like it when students show work. When I say show work, I mean show steps. So this one, you would, subtract x from both sides, maybe add 6, get 4x equals 8, divide by 4, divide by 4, x equals 2. By the way, not a bad idea to check your answer. You could always plug it in for x. 5 times 2 is 10, minus 6 is 4. 2 plus 2 is 4. 4 equals 4. That answer works. Another way to check your work, this would be kind of a little bit strange, but if you graph both sides of this equation, let's just try it. So I'm going to graph this side in blue here, so this will be 5x minus 6. So let's see, minus 6 right here, slope of 5, so 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. Graph looks something like this. It's hard to get exactly, but there you go. And this one would be x plus 2, so has a slope of 1, so it makes some slope points there. So if you graph that, it definitely crosses at, it looks like 2 comma 4. And notice our answer a second ago was x equals 2. Well, that makes sense. X is equal to 2, y is equal to 4. So the answer is x equals 2. So where they cross is a different way of looking at the problem graphically, but you could say that where the point, the x value where they share is their solution to the problem. So here's the question I have for you is, do all linear equations have one solution? So it seems like, you got two lines are going to cross in one point, and so you might have one solution. But let's just kind of check that out. So this is at least a little bit more interesting. It's got some distributive property. That's nice. So 4x minus 4 equals 2x plus 2x plus 1. So we get 4x minus 4 equals 4x plus 1. I guess I'm going to subtract 4x from both sides. And wow, so 4x minus 4x is 0, so I get negative 4 equals 1, which, by the way, is not true. So what's the solution? What's the answer here? I know that we could, well, I mean, the solution is no solution here. I mean, there is no solution. There is no answer. Negative 4 is negative 1. It doesn't matter what x is. Those two things are not going to be equal. If you look at this graphically, it might just help your understanding this. So 4x minus, if you look at these two equations, 4x minus or plus 1 looks like this. 4x minus 4 looks something like this. Those two lines are parallel. So that's why there's no solution. So just because they're two linear lines doesn't mean the graph is always going to cross at one point. Sometimes you have parallel lines. In this case, there would be no solution because those two lines do not cross at all. Let's try this one. So a very similar problem, 4x minus 4 equals, distribute there, so 2x plus 2x minus 4. So 4x minus 4 equals 4x minus 4. You might even stop there, but if you did subtract 4x, get negative 4 equals negative 4. Well, that's always true. So the solution is all real. So if you look at the graph of this, what this means, if we graphed each side of this, 4x minus 4 looks something like this. 4x minus 4 looks something like this. It's actually the same line. There are an infinite number of solutions there. Okay, so similar to what we did last chapter, but this is now with an equation. So with equation, it's really nice. Instead of having to multiply by the LCM, you multiply everything by the LCM, because as long as you multiply every term on both sides of the equation by the LCM, the denominator will just fall off. It'll just go away. So you have to find the least common multiple between 6, 3, and 4. So multiples of 3 are like 6, 9, 12. 12 looks good. So I think 12 is the LCM here. So 12, so if I multiply everything on the left-hand side by 12, not in the numerator and denominator, only in the numerator, so by 12. So I'm going to multiply the numerator there, so that would be, I'm just going to write it out the first time here, 12x over 6 plus 24 over 3 equals 36 over 4. Wrote it out, but really you just go ahead and simplify. A lot of people skip this step. They'd say 12, 12 cancels with 6, it's really 2x. 12 and 3 cancel, that's really 4 times 2, that's 8. 36 divided by 4 is 9, so 9x. So you can see with one step, basically, 1.5, 2 steps there, we got rid of all the fractions, right? So that's really nice. Now we're just solving kind of a normal equation, 2x minus 2x. Get 8 equals 7x. Divide by 7, divide by 7, x equals 8/7. You can always check that by plugging it in, make sure it works. Because it's just a touch harder here. So we have a denominator of x minus 1, we have a denominator of x plus 1, and a denominator of x squared minus 1. Now, hopefully, when you see this, I hope you really think this. Right? It's difference of squares there. In fact, it just so happens this one is made up of both of those other two combined. Right? So you could try to get the same denominator, but I think it's better just to multiply by the LCM. So the LCM here is actually x plus 1 times x minus 1. So to multiply, this is going to be kind of weird. So I'm going to multiply the left-hand side by x plus 1 times x minus 1. And I'm going to multiply the right-hand side by x plus 1 times x minus 1. And so these two get multiplied by the first term here. When that happens, can you kind of see that the x minus 1 and x minus 1 is going to cancel? So you're left with 4 times x plus 1 plus multiplied by the second term. And hopefully you see that the x plus 1 and the x plus 1 is going to cancel, so you really have 2 times x minus 1. And when you multiply this one, you can, because it's only multiplied by one term, I'm going to go ahead and cancel out x plus 1, x minus 1, they both cancel, you just left with 35. So here's the beauty. I mean, we had this really, a lot of fractions, and just by multiplying by LCM by every term, we have a pretty normal equation now. This is a linear equation. It's not bad. Distribute there, 4x plus 4 equals, plus 2x minus 2 equals 35. So 6x plus 2 equals 35. We're going to subtract 2. We're going to get 6x equals 33. Divide by 6. Divide by 6. Get x equals 3 goes into that, so that'd be 11 over 3 goes into that 2 times 11 over 2, 5/2, and you got it. Again, you could check that to be sure. In fact, it's a good idea to check, especially in the denominators. Make sure the denominator doesn't equal 0. We'll talk about that more in a minute. In fact, let's talk about it here. So this is a good problem. So it's got a denominator of x minus 4. So the LCM is probably obvious, but it is x minus 4. It's the only denominator, right? So we multiply every single term by x minus 4. So we multiply both sides by x minus 4. Distribute here. So the first goes to the 2, so that'd be 2 times x minus 4 plus distribute to here, and you can see that the x minus 4 and x minus 4 is going to cancel, so you get plus 5. And here clearly when you distribute, the x minus 4 cancels, so you get x plus 1. So I'm going to solve this guy. See what happens. You get 2x minus 8 plus 5 equals x plus 1. 2x minus 3 equals x plus 1. Subtract x. Get x minus 3 equals 1. Add 3. X equals 4. So you'd be very tempted to circle that and think, oh, I got it, right? But here's the problem. If you were to plug this back in, and I'm not so worried about the numerators, I'm always worried about the denominator. So if you plug that back into the denominator, 4 minus 4 is 0. You can't divide by 0. Same thing over here. So 4 minus 4 is 0. Can't divide by 0. So this is not a real solution. It's called an extraneous solution. The answer is no solution on this problem because there was only one answer and it was extraneous. So always check your answer, especially when there's a denominator and x is in the denominator. That's really the time that you need to definitely check your answer. And that's the lesson for today.